Well, hi, good morning. Thank you so much for joining me here. It's February 5th. Man, it's cold here again. It's minus 15 degrees outside, blue sky and sun shining, but wow, it's cold. So, okay, hey, another tube tester. And this one, at least on the outside, looks pretty much like the last one. So let's look inside. It's a little lighter. The other one, the last one I did, about the same size as this, was very heavy. This one's not nearly as heavy. And the heaviness has to come from the big transformer that inevitably is in here. Well, this looks pretty simple. Really, it's a Stark. That's interesting. I think Stark kind of became the lead maker of test tubes. Tube testers. Okay, let me take this back off here. Let's take a look at this. So what's going on here with this thing? So obviously you're gonna slide this, and you're gonna do tube 25S. I've never heard of a 25S. See additional tube list on number 2 leaf. Number 2 leaf. Looking for a date. So I guess you got to slide this all the way down to here in order to free these pages up. So I'm just glancing at the tubes I'm looking for. Yeah, there's lots of 12SJ, 12SG. Lots of tubes with the single-ended tubes, basically. Well, date. Anybody show me a date? Tube test index for Stark models 911, 955, and 954. That's interesting. The tube tester I use the most is the 966. Just sitting here to my side, to the side of me. Instructions are there. Special test information. Okay, that's the information we have there. Poor and good, and just a scale goes from 0 to 60. 0 to 60. It's a little odd. Okay, so the fact that it's poor and good, and I'm sure this is just a, oh my gosh. Oh. I was going to say this is not a dynamic tester, but the word dynamic is right here. Dynamic 3 control. Line test. Tube test. This is the Dynamic 3 control. Comes complete with the Dynamic 3 control. Shunt. Line test. No, shunt. This must be referring to this. Shunt. Could be the plate load resistor. This control. 1A, 2B, 3C, 4D. Why would they do that? Why not just 1, 2, 3, 4, 5 all the way around? Battery test terminals. Press for 6 volts. 6 volts. 6 to 60 volts. Battery test. Press for 6 volts. Well, where do you get the 6 volts? Continuity test. On-off switch. Filament setting. Again, they didn't write the voltages here. They just have numbers, so you have to rely on the information to set that. Short indicator, line adjust. I think there's a good chance I've never plugged this one in. So I really don't know what to expect. What is this? Oh, that's a 2-pin straightener. That's cool. Well, what's this one? Another 2-pin straightener. Wow. This is for high production. This is for you mount that on the wall and you're doing a lot of tubes. I have some other straighteners. Maybe I can compare them later. Okay, This obviously is the cap connector. What's this? A piece of wire for no reason. Okie doke. We should try testing a tube here. We'll try the 53 because I'm quite familiar with it now. So 53 is right on the front page here. 53. So we'll just try setting it. It's only three knobs. You know, how much instruction do you need for this? Yeah. That's something you'd never want to hear your doctor say, that's for sure. The special test information. Oh, so there's the letters down here, A, B, C, D, E, F, G, and then I guess those letters are appearing up here somewhere. And so then you can jump to, here's one like V on a 50Z7, which I've never heard of. And you find V, it says, good tube will show short on selector positions D, 5, and E. That's not instructions though. Okay, so if we want to do the instructions, '53 at the under the line. Four. This is not very helpful here. 4, 36, and A. 4, 36, and A. Well, you know, if you put numbers on one control and put letters on another one, you'd have a hard time confusing the two controls. But mixing it like this, I still don't understand why they're mixing it. Okay, that's about it. What else are we supposed to do? There should be a short test here somewhere. There must be more instructions. See if we can spot a short test. And the word short show up. It has a short indicator. How do you do a short test on here? So I'm going to go and get a cup of coffee. I'm going to look more closely at the documentation I have and see if there aren't some instructions in there somewhere. I just missed them. But coffee is the main thing. So I started looking around on the internet the usual way, you know, searching in Google, what can you show me about this Stark tester, what can you tell me about it? I couldn't really find anything easily. I thought, well, why don't I try Copilot? Let's see what the AI system for Microsoft has to say. So my first question is written here. Are you familiar with the instructions for a Stark 955? And here's his response. Yes, I'm familiar with the Stark 955 tube tester. It's a portable device used for testing vacuum tubes, commonly found in vintage electronics. The Stark 955 can test a variety of tube types and is known for its reliability and ease of use. Would you like a brief overview of its operation? Or are you looking for specific instructions or troubleshooting tips? Oh my God, really? Well, I want a brief overview. A brief overview. I thought I'd do this live on my channel here. You can watch all this. In case you're not doing this, I'm trying to encourage everybody to do this. I'm trying to encourage my wife to use this. She refuses to go near it. So anyway, how can you not go near it? Here's a brief overview. Plug the tester in, allow it to warm up for a few minutes, ensure all controls are set to their default positions. Okay. Select the tube type. Refer to the tube chart on the tube tester accompanying manual to find the settings for the tube you want to test. These settings will include filament voltage, plate voltage, and other necessary parameters. Except they're not really listed that way. They're just numbers. You know, you don't really know what you're doing. Insert the tube. Carefully insert the tube in the appropriate socket. Set the controls. Adjust the controls to match the settings specified in the tube chart. Shouldn't you do that first before you stick the tube in? Perform the test. Press the appropriate test button to initiate the test. Well, there only is one thing. Just a lever goes to tube test. That's all I see there. The meter on the tester will provide a reading indicating condition of the tube. Interpret the results. Compare the meter reading to the chart to determine the tube's condition. If the needle is in the good range, the tube is functioning properly. If it's in the weak or bad range, it may need to be replaced. There you go, man. What a world we're in now. You don't have to go to the library and find a book. there's a guy here who's read every book, and you just ask him what's in the book. Okay. I think it's pretty straightforward, really. Okay, without any tube in it, let's turn it on and see what happens here. Like I say, I think this is one tube tester I've never turned on before. Okay, so we're going to take it down to one light bulb. It's got a huge transformer in it. And if there's a short to transformer, we don't want to slow down the wheels and the generating stations on the power system. Here we go. Because the switch is off, nothing should happen. 120 volts. Hey, that's a little high. Okay, I'm going to turn the power off, switch this on, and turn the power on. Okay, so this should have popped up here, shouldn't it? 103 volts. There appears to be no current going into this device because the bulb is showing no. I didn't put the camera up. The bulb did not come on at all. So, a remote possibility it's not plugged in properly here. Very remote. Line test. Let's go with line test. Okay, so yeah, line test, and then this should come up. Let's see what happens here. Bingo. Okay, line adjust. Ugh. Okay, we'll leave it like that. Oh, the line test is right here. It's looking in the wrong spot. Precision. Stark, made in Canada. Okay, well, I guess that would be it. Now I think we should set these controls before I stick a tube in, especially the filament control. So it does say filament here. So this is the filament voltage control. We know that 53 4 53 36. Well, I already did this. 36. I did do this. And I did do it. Good show, Jim. Okay, now. So usually these sockets are arranged so the fat pins, the filament pins, are on the bottom. Not always. I think this is heading here. I think not. I think it's heading here. So on the socket they put a little tiny dot right here, again, to mark the two filament prongs. Going in. Wow, so hard to put in. Oh my gosh! That can't be normal. I don't know, I think it's in there. Okay, so nothing's happening at all. I never read anything about short indicator, so I don't know how that's supposed to even operate. It's supposed to come on while I'm sticking it in, maybe. Tube test. Tube test. No, that's in the socket all right. Did not heat up. Filament on 4. This is probably voltage here. Filament 4. 36 and A. What do you do? Line test. Tube test. No response at all. Nothing at all. Well, in situations like this, what I like to do is go and drink coffee. That's what I like to do. Oops. Screwdriver's mixed up there. Maybe I'll leave this in here for now. Yeah, I'm going to go and ponder the situation, drink a little coffee, and see what's happening in the world. We should try another tube. So I want to try a 6SK7 that I have here, which has been repeatedly tested. Well aware of its condition. Here it is, 6SK7. So when I look at this chart here and this thing, I see the wings out here. I'm wondering, what the heck is this for? So let's take a look at the 6SK7. Here's the 6SK7 here. I'll slide the slider up. And you'll see what those bent parts are for. 6SK7. It's to hold the page up. What's John, what are we going to do about that? I don't know. I never thought of it. What about, I don't, just bend the ends up. Yeah, okay. Bend the ends up. Okay, 6SK7. 6, 35, and B. There's only 3 things to remember. 6, 35, and B. Oh, this doesn't even click. Wouldn't you expect this? Oh, this might be the problem here. Is this even turning? Or is the knob turning on a stuck shaft? Oh, I think maybe. Oh, you know what? This is, don't make a mistake now, Chip. If it's spun on the shaft, then we don't know where this is pointing, you know. If it hasn't spun on the shaft, I had better, okay, see. I had better know what I'm doing here. See. Holy smokes. I'm not gonna make this one, won't make it, that's for sure. Big. Ugh. I don't know. I don't think it's working. I don't think it's loose on the shaft. Well, that's pretty weird, because I thought this would be I thought it was a snap switch. Doesn't that make more sense? Doesn't make any sense. Oh, those Stark engineers. Okay, so B was the thing though, wasn't not? B. 6, 35, B. Okay, we will stick this in. Switch on the power. Is there no pilot light? There's nothing here that indicates it's even on. Well, we can do this line test. You can always line test it. Yeah. Okay, there's nothing more to do. So this sits in a position. No, it doesn't. Dynamic 3 control. Oh, 3 control. What's dynamic? I just wanted to get that word dynamic on their tube tester here. Whoops, I guess I bumped the camera a little bit. Dynamic. Okay, tube test. Here we go. She's a dud. I don't think that. So something more serious has happened to this tube tester. Is there a fuse sticking out? No. But it will do that. What happens if you press for 6 volts? Continuity test. How do you operate the continuity test? Probably by picking some setting down here. Well, let's take it out of its cabinet and see what's going on underneath. And I'm not very hopeful for this at all, but let's take a look. Get some fun value out of it. Okay, all those screws are out. Let's see if we can lift this out. What should I grab onto? Ooh, ooh. Sounds like this. Here we are. There we go. Oh boy. switches and wires. Not much else. So just looking it over here, for anything unusual. Pretty strange looking guy here. This wire is cracked. This is the power wire. So what has happened here is it would look like somebody has put a different cord on and they've connected it here and soldered it to the terminal there after changing the cord. Maybe not. Maybe this is the original. This is friction tape here, which is actually really long-lived effective tape. It becomes very, very stiff after a while, as opposed to electrical tape, plastic tape. It may not have had plastic electrical tape back when this was being made. But just above it is a fault in the insulation, and I can see copper right there. Potentially, I guess, if you were tugging on the cord or doing something, you could maybe swing this into something. I don't know. Doesn't look like it offhand, but just making observations here. So we do have this. This is the 6-volt switch here. This rather odd arrangement down here. Oh, look what it is. So each one of these is a wire wound resistor. And then this is the adjustment, this arm here. You can see this one is pushed over. These two are straight down, as if they've been left in the neutral position. I was going to say, that looks like an adjustment. No. There's another one of these weird things. I don't know what they are. Let's take a closer look here. Let's do that. I'm going to stop for a minute and freeze the automatic focus on the camera. Okay, let's take a look. Oh, the wires are tangled up here a bit. Here we go. Oh boy. Is this some cat activity? What's going on here? Okay. Oh, sorry about this. Okay, we'll just start in the top right-hand corner, top left-hand corner, and just kind of whip through here. So, nice looking sockets. I think they're all pretty good sockets. That's the power switch with the incoming power cord here. Does it look resoldered? I don't think you can really tell. Hard to tell. Okay, and here's the damaged area here. Maybe it's not copper I'm seeing under there. Well, this is really kinked. This is kinked quite strongly here. Huh. Okay, I don't think it's of any real consequence. Here's the big honking transformer. This is the one of the switches here, and here's this first one of these guys. I think it's a wire wound resistor. Let's get a little more light inside here. That's what I think it is. There's a couple more down here. Ooh. Huh. Not too often I find things. I just have no idea what that is supposed to be. If you look at the wire terminals, okay, so the very bottom piece you can see a little better. Let me get some more light on here. It is wire wound around it. So I don't think there's any reason to have a coil in here. From an conductor point of view, I think it's got to be a wire wound resistor. Wouldn't be a very good conductor. Here's another one here. They all, I mean, that looks like it's been hot, and the goop has gooped up. Same thing with this other one. It looks like it got hot, or somebody painting something on there. It's weird looking. I don't know what to make of that. So here's these wire wound resistor adjustments here. This one's glued. They're glued in place. They've been glued down. So you're not really supposed to fool with these things. Done once in the factory. This could easily have lost contact here though. Okay, so underneath this plate is the meter body sticking out. Here's a big honkin' rheostat here. This is the line adjust. Ooh. Is it? So line adjust works. So we know it's working to here. Doesn't help much. It's got 3 terminals on it. So you have the 2 outside terminals, and then you've got the rotating terminal in the middle. 3 terminals. So this is a this is the thing that I thought would be a snap switch. It sure looks like it should be snapping, because look at this. They got 3 things connected together here. Well, I got 2. And is this really how it's supposed to work? Well, what would stop? What would make a snap switch no longer snap? Oh, there's some words here. What does it say? It says sockets. What? Sockets. Come on, get out of the way. Sockets. Ah, hang on here. PF. Okay, so you know what this is? The guy who wired the sockets signed his work. That's what this is. A long time ago when I was a kid, I saw a video about the idea that if everybody signed their work, the world would be a much better place. And they showed a guy painting a yellow line on a road while they're talking about it. And at the end of his day, when he finished painting his yellow line, he sat and wrote his name in paint on the road as a, to show how it would work. And you know what? I bought that. I bought into that. That's why I firmly believe when we're on the internet, we should be using our names and not, Big Boy 642, stuff like that. That's nonsense. That's part of why the internet has gone the way it is. People hiding behind their names. I told my wife the other day, to me, the internet, a large part of the internet, was around when we went to high school. And she said, "What are you talking about?" And I said, "Yeah, didn't you ever go to the washrooms and sit down on the toilet and look at the wall? And all that stuff written on the wall, that was the internet. That was where you could say anything you want and nobody would know it was you who was saying it. For a good time, phone this number and all that stuff. And some pretty funny jokes. But to me, what we used to do, I never wrote on the walls of a washroom myself, but what a lot of people used to do, because they had free reign in the washroom, it revealed their selves, like the internet does. Oh, this switch looks to be in. Oh, this looks bad. What's happened here? That's right, so internet. Washroom stall. Well, there's nothing soldered to this last terminal here. That seems to be bent out of place. There's nothing soldered to it. Let me, oh, this is the, so this is the line test going this way. And this is the test the tube. It's funny how they've done this. It's not bent. This is on purpose. This one. Oop, sorry. Let me turn the camera around because it's confusing me too much. Here we are. Okay, so this one on the end here has not got a connection. It almost looks like the tip has been cut in half here. But you see there's a wider flange down there. Now look at the other side of the switch. The same sort of thing's happening. This contact looks shorter. Here's another one. These are all shorter. The shorter and longer ones, Jim. They're shorter and longer ones. The longer ones maintain contact all the time, and the shorter ones are the ones that are being switched. Okay, so here we go. So the two contacts we're kind of looking at here, these two here, do they ever come out of contact? Oh, I gotta go the other way. Yeah, if I go the other way. Yeah, this is the line test way. This is the test way. So I'm looking for is movement in the contacts as the contact bar reaches them. It's hard to, I'm not holding, I gotta hold the camera really still to do that. Yeah, see that pop up and down? You see another one popping up and down. Yeah, it's popping up and down. So all the ones that are making temporary contact are making contact. There's no doubt about that. Don't think there's anything wrong there. Let's look at this one here. This is the one that I thought should be a snap switch. So you can see one contact is constantly in contact with a rotating ring. As we go around, we're selecting. But it just, I think we can get three things connected at once there. It looks like you're just, okay, let me look at the actual setting here. We'll put it right on something. We'll go to the end. Go to the end. Well, there is no end. There is no end. Okay, we'll put it right on the number 6 there. Right on the number 6. It's pretty clear what it's doing here. It's just tying those two together. And no doubt that's a setting. And then now look at this. We've got three things in contact here. What do we got happening? We're kind of in between. It doesn't matter what you do with this switch until you throw the lever. Maybe that's the situation. So the fact that it's, you know, connecting all kinds of stuff while you're rotating the switch doesn't matter. A, right on A. What do we get this time? So it's clearly connecting those two together and to this one, to this one here, and those two. Okay, let's see. Are the switches springing up? Again, I have to hold the camera very, very still for this to work. Let's see if I can just make it sit here. Okay, let's try that. Yeah, so you see the fingers are going up and down. We can go all the way around. A little out of focus, but still see them all move. So, you know, unless the switch is just plainly dirty, which it just appears to be to some degree, but not terribly dirty. Look right at the contact surface. I mean, it doesn't look that bad. But it's possible. What about down here? We got this 6-volt switch. And, well, So a possibility is the transformer is pooched and there's no voltage to drive the unit. So you can measure the incoming voltage when you do the line test, but you can't measure or find any voltage on the output. So that's a test we could do. We could poke around here and try to find some voltage somewhere. Any voltage anywhere would probably do the trick, improving the transformer still operating. Can we identify? So there's wires going in this side. Certainly the primary is going in this side. We have a bunch coming out here and a few more coming out over here too. So, but any one of these should have, I should be able, like this one's going off in a different direction. And these ones are all going over to the switch. So maybe this is the ground. Can we call it that? It also comes to this terminal, which looks a little special too, and then carries on up around and gets onto this thing. Who knows what's going on? What a nightmare. What a nightmare to think this thing through and come up with this deal. But again, I'm sure these things were developed, one machine at a time, each machine being a little bit of an improvement on the last, so you don't have to think this whole thing up out of the blue. Yeah. Okay, we should probably test for transformer output. That's probably the smartest thing to do next. And see if there is anything. Got all these wires here to test. Surely somebody's going to have some voltage on it. Don't call me Shirley. Okay. Put the switch. It's unplugged. I'm going to turn the switch on. I'm going to go like that. I'm going to grab a ungrounded, just a multimeter here. And we're going to put it on big AC voltage, 600 volts. And what we're dealing with. There. 600 volts AC. Okay, I'm going to plug this in. It's already turned on, but it's not in the test position, so we don't really know for sure. Yeah, these wires are coming out. Yeah, we do know for sure. Okay, here we go. Power on again. No, it's like nothing at all happened. Let me what I'm going to do is I'm going to watch the meter and flip it over to line briefly, just to make sure. Don't get a shock now, Jim. Yes, okay, it went up. Okay, so we're good on that. Mr. Transformer, do you have any voltage in you? So I'm going to guess this is the way to go. I'll probably just go right on the chassis, actually. And any one of these. How about this one? Oh, for crying out loud. Okay, two things at once. It's not a good idea. Like this. You can't look at two places at once. Even though we have two eyes, we can't do it. So we're going to go like that. Bearing in mind, I have no idea really what I'm touching there. Okay. Getting funny readings here. Here we go. How about this guy? 13. How about this guy? 6. How about this guy? 5. How about this guy? 3. Okay, how about we go the other way? Let's go this way. 30. How about we just keep going? 50. Oh, I'm using my left hand. 75. It's just going up in voltage. Not surprisingly, 123. And 29 again. So we're starting over, or I don't know why it's 29. So voltage is working. So bad switch contacts. The tube did not heat. Isn't that right? I did not see the tube heat. The tube heater adjustment. Oh my gosh, this is the filament adjustment. This is it right here. So let's just see how this works. If we select, don't forget it's on, man. We select position number 2. We have selected what? Position number 2. We have selected, you can't quite see it, but it's right here. We've selected that. Position number 2 is 2 volts. Well, it makes sense. Now, the heater. Is this the heater? What is this? This is the line adjust. What are you doing, Jim? Come on, smarten up. So why didn't you work? No heat, no heater. So the heater setting is here. What am I doing? Clearly I'm in need of coffee, really badly. So look at this tube socket over here. Only has 1, 2, 3, 4 wires coming to it. So 2 of them are bound to be the heater. Usually it's 2 and 7. 2 and 7 right there. Let's measure that voltage between 2 and 7. I'll leave the ground on here for some stupid reason, and we'll measure it right down this way. So I see 12 on the meter. And over here, a 0. A 0. Good. So there's 12 volts on this heater circuit. It probably is because of the setting of this switch. So for instance, I go back on here. See 2 volts. Did I say 12? Why did I say 12? Where did 12 come from? 12 is up here. We're attached to this wire now, but we're coming around this way, so we're getting to the high wires. I didn't leave a tube plugged in. No. High wires. High voltages, rather. Yeah, it's all coming through. But let's look at the actual socket I was using. Now, the socket I did 2 tubes and neither one heated. So it appeared. So we would want to go, I believe it's into this socket here. So has anybody got which voltage? We are switched on to I think it's this one here. 6.9 volts. So we're looking for 6.9 volts on here somewhere. Whoa! 150. Where's that coming from? 150. That's 13. $150. I really have no idea what they're doing here. Let's put this on the 150. Change the heater. Shouldn't change it. Yeah, so this is probably the plate voltage. I'm on AC here. So a lot of these tube testers, they in no way do they operate the tube like it is in a radio or something like that. They operate it in a way that they can achieve the measurement result accurately. And so they try to do it with the least number of components. If you notice, there's no rectifiers in here, there's no capacitors, there's no DC B plus in here. So they're doing everything with 60 cycle AC power. I believe that's the case everywhere in here. And I think that was a Stark trick. Stark, or a company behind Stark, another company, came up with Hickok came up with a test technique where you didn't need to produce a DC B plus. You could use AC and just basically hum the tube like crazy, but still make the appropriate measurements and observations in it. Hope that's true what I'm saying. You get 13 volts with this just floating around in the air. Nothing seems to be wrong, yet 2 tubes have failed the test. Okay, we'll do this. I don't know what to do. We'll do this. We're going to spray some cleaner on these switches, even though they look just fine. But who knows? Maybe there's something going on in the back here I can't see. here. We're not turned on, right? No, not on. Timber. That's from rushing a bit. You're rushing a bit, you have an accident. Okay, it's not exactly an accident of consequence. I just dropped something here. Okay, next switch. Weird one. There's a switch in the back here too, is there? There's terminals everywhere on the backside. So I'm going to spray some stuff there too. Okay, so feel like gambling? What? Put your money down. Did this help? I would bet no. I would bet this thing has not changed one bit. But we're going to find out after I drink a little more coffee here. Okay, let's try this 6SK7 again. Geez, is there a chance I plugged it into the wrong socket here? It doesn't really tell you what socket, does it? It really doesn't. Okay, so just double checking now. 6SK7, 635 MB, 635 MB. You know, when we had this thing flipped over, I never saw this control. And I checked it briefly. The big transformer is hanging right in here, and this is up above the transformer. Is this actually feels like a regular rheostat though? Okay, and it was 35, wasn't it? 35. I'm fooling with it. There we go. 35. Okay. Power on. Tube in. Can it go in here? Oh, it can go in either one of these. What's the difference? Oh, even in this one. These three are the same. What's happening here? There's another one over here. I think there's another tube straightener here. This thing right here. A lot of pin straighteners going on. Maybe not. Maybe not. STD. Looks the same as these actually. Well, I don't know what's going on here. These are numbered. These are not. These numbered ones, did they never appear in here? Do they? No, they don't. Such a mystery. Well, let's try a few different sockets. Now, there's only one that would receive the 35, the old 35 tube. Or is there? What about this one? 1, 2, 3, 4, 5, 6. No, this is a different 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I put it in here. I did put it in here. Okay. Now, can this really go in? This is off. Can this really go into all these different sockets? It can. So, what's the deal here? And then this one. Well, okay, these ones are numbered. So assume this is something special over here, and this is the usual place. So I got a place in the usual place. Let's try it over here. Okay. What do I do? Just turn it on at this point because I've got it. There we go. It is on. There's nothing to warm up. Okay, line test gone low because I turned this down over here. Turn it back up a bit. Hey, what's going on here? Short indicator. Really? Don't put it in that socket, Jim. Short indicator. I think the tube's warming up a bit. There's no short in this tube. I've got another one, 6SA7, which I know is a good tube. Let's try the 6SA7. We'll see what happens with it. So 6SA7. Two tests. First test, 634. 634. Oh, did you see the light flash? I'm getting a little more out of it now. Maybe I did clean these sufficiently to do something. If we stick it over here now, 634, we see, hey, no short indicator. Short indicators, come on. Generally speaking, if you detect a short in a tube and you try to test it, you run the risk of damaging your tube tester. Go over here to number short, short, not. Tube test, line test. Huh. There you have it. It's fantastic. Okay, let's try something else. How about it's got some small sockets here. Can we do? Oh, but I won't have. I'm gonna have a hard time finding a tube that this thing will test, other than these old guys. Well, let's go for another old one here. It's not gonna do that. 5Y4, not old enough. You get this big honker here. 6B4. Is that in here? 6. Oh, well, it might be in this list. 6E. Where's 6B? What's going on over here? We got one. Well, you read right across. Oh, for crying out loud. Really? 6. So then what? Then you open these up and you got the next page? So how's this supposed to work? Six E, 6A. What is going on here? 6B4, 6B. Not going to show up. Not going to show up here. Wait a minute. 6B4, there it is. Okay, I found it. Not sure how they got this list arranged. 639 in C. 639, this is a fast tester in C. Too bad it doesn't work though. Okay, this is a whopper of a tube. And I don't know the condition of this tube. I have not tested it in another tester. Interesting marks on the top of it. See the X? And all kinds of other little marks on top of here. Once again, so it doesn't instruct you on what, where to plug this in, and we got 4 choices. So we're going to go here, 6. Let me check it again, 6B, because I am nervous about doing this. 6B, B, 6B4. Where'd it go? Where did it go? 6B4. 6B, there it is, down here. 6B4. 639 and C. Yeah, 39. Okay, I'll stick it in here. Line check. Stick her in here. No short indicator. Line check. Oh, short indicator came on after this thing started going. Is it possible that a half indicator, like a half light, only half the light is coming on? That's just something to ignore? The tube is heating. The tube is heating up. You know what? Let's ask the Oracle here. Okay, Mr. Know-It-All. My tube tester is showing a half lit neon bulb with all tests when the tube is plugged into the socket. What does this mean? And then in brackets, only half the neon light. Okay. What do you say, man? Chew on that. Half-lit neon bulb on your Stark 955 tube tester typically indicates a partial short or leakage in the tube being tested. This means that the tube isn't completely faulty, but it does have some issues that might affect its performance. So, okay. Should I proceed with the test procedure? Okay, procedure. It's generally not recommended to proceed with a full test procedure if the neon bulb indicates a partial short or leakage. Testing a tube with these issues might not provide accurate results. It could potentially cause further damage. Instead, inspect the tube, clean the pins, test another tube. Try testing a different tube to see if the issue persists. I'm in the middle of doing that, buddy. This can help you determine if the problem is the tube or the tester itself. If the issue continues, it might be worth consulting the manual for troubleshooting tips or seeking help from a professional. Yeah, I'll seek help from a professional. Okay, I don't think there are any shorts in these tubes. That's what I think. Okay, back to the screen here. Okay, let's give it a shot. What we're looking for is a response up here. Here we go. Well, that's not bad. So notice the short indicator goes out when you do the test. I kind of wondered if that would happen. Steady reading on the meter. Looks like a valid test. Now we're going to play around with this shunt thing and see how sensitive. Very sensitive. So a little adjustment or a little inaccuracy in this control, you could turn all your good readings into bad readings. That's pretty easily, I think. So supposedly this is poor. Let's try another tester. We'll find out one that I trust, which I hopefully we can do it, and that's this guy here, the 6B4. See if it's on the list. 6B over here, 6B4. 6B4. Okay, let's do it. So 6.3 volts. JR53 and zeros. JR53 and zeros. JR53 and zeros. 67 and 82. 67, 82. We're on the 3000 scale. This should good tube. A tube in like new condition. We'll put this meter right over all the way. And if it only goes to 1900, should be down about here, time to sell somebody a new tube. Okay, 6.3 volts. There we go. Because that's probably drawing a heavy current. We will check the line. Slightly low. And the tube is heating up. Short test, watching this light. So this guy finds no shorts. I'm pretty sure that's going to be the truth. Push P4 and where did my 6P4 go? 1900 and 3000. 1900. P4. Look at that. It's a good tube. It's worth some money. Tube is good. So Now, I did not use the replacing good scale. Why don't we do that? Put it back in. Wait a moment. We'll flip this to English. So now it's just replacing good. In case you don't want to think. Good enough. Barely good. So the other tester was coming up here, and this one's coming up here on the good-bad test. So other tester, sell the tube. This one, you might have to convince the customer. Or you can sell them a new tube. 6B4. Okay. Now, what else are we going to do with this tester? Is there anything I'm going to do with it? You know, honestly, I'm not going to sit there testing tubes with this. This is more just having some fun checking them out. What's coming soon, though, are the testers I actually use. Not quite yet. The next one, the next one. The next tester we're going to look at tomorrow is one I've had on my bench and done a fair bit of work on it. It's a very, very complex tester. It's closer to a lab tester than it is a field tester. Looks to me like it's kind of in the middle of that. And so that one will be much more complicated. And I'm going to have to remember how to use it too, which will be difficult. Let's pick this up. This is not the easiest thing to... Who thought this idea up? Holy smokes. There we go. Okay. Hope you're enjoying the series here. And like I say, tomorrow I'll have something much more complicated here. See ya.